Good afternoon, ladies and gentlemen. My name is Kwok, and I'm a member of the Professional Information Security Association, PISA. And PISA is very famous in Hong Kong, so I don't need to introduce PISA to you. We have been here for over 10 years. Actually, during the break, I saw Hong Kong invite me to give some keynote or speech about DNSSEC. Actually, I wear two hats. My second role is working in the government as a senior telecom engineer. The government is adopting a technology-neutral approach, so I cannot say something in favor of DNSSEC. I am technology neutral, so forgive me about that. Okay, the topic today I am going to share with you is DNSSEC deployment from a level administrative perspective. I'm not expert. I don't have the insights of ICAM, and I'm not the trainer to teach DNSSEC, so I just look at it from a very general level administrative perspective. I do have some slide about PISA, but I don't want to introduce PISA. You can go to PISA website to have a look. So if I start, I would like to introduce cache poisoning. You will remember in the first section, Richard gave us a presentation about a band. The IP address is two IP address 1, 2, 3, 4. The fake IP address is 5, 6, 7, 8. That's exactly my IP address in this slide. And he used a band in Switzerland. I use a band in USA. So in this slide, for a properly configured resolver, the chance of getting cache poisoning is 1 in 4 billion. The 1 in 4 billion protection is off by transaction ID 16-bit, and the random source port number also 16-bit. So given the software bandwidth and large number of zombie computer, there is a chance that a hacker can inject fake answer or bogus answer into the resolver. Look at this. This is for the configuration of properly patched resolver. How about those unpatched resolver? For unpatched resolver, it might work on a static source port. Then the chance is reduced to 1 to the 2 power 16, which is 65,000. So you see, cache poisoning is not difficult. So what are the impact of cache poisoning? Quite obviously, it will give you a different IP address. It can insert a fake host name and redirect you to a login page and get your account name and password. And some people may not notice that cache poisoning can answer something like, oh, the domain you are asking does not exist, and you will not be able to get into that website. This is a denial of service attack. And people generally have the idea that only positive answers are cached, but negative answers are also cached. The amount of time is set on the SOA, the state of authority. You can play with it if you have time. So why DNSSEC? Actually, in the previous two sessions, we know why we should use DNSSEC. The present protections of return IP address, transaction ID, and random port number are too weak in today's hacking environment. So we need DNSSEC. DNSSEC can allow resolver to verify the source of information layer by layer by means of digital signature from root-zone to .com to abc.com. So after a resolver has been DNSSEC enabled, it will do the validation. So another name for resolver is recursive validator or validating resolver. Those two names are very difficult to remember, so I just call them resolver. So what are the roles of a level administrator in order to run DNSSEC? Well, they have to generate key pairs, sign the zone key pair, publish the zone record, and then change the key and sign the key again. I want to draw your attention to some word, resign, R-E-S-I-G-N, and resign, combining together, R-E-S-I-G-N. They do have some similarity. If the resign process fails, all your internet service, your email will lose. You have no other choice but find another job. That is resign, R-E-S-I-G-N. And after you have successfully signed the song, you have to pass the public key to your parent song. Who is your parent song? Suppose you are running abc.com. Your parent song is .com. So you have to pass the public key to your parent song. But VeriSign will not accept your key. You have to do this through the registrar, the accredited registrar, like Level Solution, GoDaddy.com. And on the resolver side, the job is quite easy. You just add the wood truss anchor. The wood truss anchor was available more than 2 years ago on the 15th of July, 2010. I didn't sleep on that night. Here is a very nice picture I found in the book by Mr. DNS Crackett-Liu, DNS and Bean, the 5th edition. In the signing process, the resources record will go through a one-way hash process to generate a digest, and this digest will be encrypted by private key and then give out a digital signature. The signed message together with the original message will be passed to the DNS resolver. In the resolver side, the resolver got a copy of the digital signature and the original message. The digital signature will be decrypted, and then we have a hash value, hash 1. And the original message also goes through a one-way hash. We have another value, hash 2. If hash 1 equal to hash 2, then the record here is proved to be good and authenticated by means of the signature here. Well, this is a picture of a successful access to a secure zone, which is icam.org. I have in this browser add the DNS related data. So there are a few requirements, to have this working. First, the song must be properly signed. The browser must have the DNS related data added, and the browser should be using a DNSS aware resolver with the wood truss anchor. If you rely on your ISP, you may not be able to do that because most ISP in Hong Kong do not have a DNS aware resolver. What you can do is download a copy of Unbound and then run your own copy of resolver at the wood truss anchor. Then you will be able to do the same. I guess the process will not be quite difficult. This is a picture about resolver stopping client to access a fake website. I have done a little trick on the resolver to poison the A record of a domain, and because the resolver get the digital signature and it can verify that the answer was wrong, and it try to stop the resolver from passing the wrong answer to the client. So this is what Comcast is doing now to protect 80 million users. If you are ISP, I urge you to do the same by making your resolver DNS aware. You will be protecting a lot of users. I tell you before, there is a term called DS, delegation signer. This is the hash of your public key. This picture shows how I pass the DS to my parentsong.com. I cannot directly access VeriSign.com, but I will pass it from my registrar, which is GoDaddy.com. When I log in, it will ask me the key tag. I have to type in the key tag number, and it will ask me to choose the algorithm and the digest type. And afterward, I have to use copy and paste to put the public key here, the hash of the public key here. And after I I click the submit button. After a few hours, VeriSign will get my DS record and sign that for me. So this is quite similar to submitting a digital certificate signing request to a certificate authority. I like to emphasize that when we submit the DS to .com, .net, or .org, we must submit those with SHA-2 hash algorithm because SHA-1 has been phased out in 2010. If you try to, it didn't, in the interface, GoDaddy.com did not tell you what's the algorithm you need to submit. If you try the SHA-1, you will fail, and if you try SHA-256, you will succeed. I think for next year for .com, we will also use SHA-2, right? Not SHA-1, okay? SHA-2, right? Sure. Not sure. Okay, thank you. It should be SHA-2. So right now, the Woodson has been signed for more than 2 years, and there are many top-level domains running with DNSSEC like .com, .net, .org, but there are still some not able to run DNSSEC like, should I say .hk, but .hk will improve over next year. So there is a very important facility we call DOV, DNSSEC Look Assign Validity Registry. It is run by ISC.org. This facility allows a domain name owner to submit their public key submit their public key to a registry, not along the DNS delegation tree. Say .Hong Kong is not signed, I can still submit my domain ending with .Hong Kong to this DOV registry. This is a very important facility, even after the Woodson is signed. I checked this morning, I tried to scan the Woodson legally, and I found that there are 93 top-level domains, including those international domain names, has been running with DNSSEC. So we have over 300 top-level domains. So we still need to use DOV if we want to run DNSSEC. So this is a picture of one of the domains under my administration. This is under .hk. I use the DNSSEC related data, and I have the public key passed to DOV registry, and my resolver has DOV trust anchor properly inserted. So I can relate it to this domain name by the DOV trust anchor. So a logical question people will ask, how can the DOV registry ensure that you are the legitimate domain owner? When you register, the DOV registry will ask you to create a subdomain name with a test record. And the DOV registry will check the test record whether it matches their own database. If it matches, then you are the owner. DOV will accept your public key. So I now turn the focus to some of the tasks for level administrator in order to run DNSSEC. Level administrator must be aware of the firewall issue. DNSSEC is running on UDP with packet size larger than 512 bytes. But some firewall, they have built-in security feature to block UDP packet larger than 512 bytes. Level administrator need to check their firewall. And how does a DNS resolver tell the world tell other name server that it can accept larger UDP? It will use the EDNS0, the feature. And once this fact is set and all the name server in the world understand that, they can exchange packet larger than 512 bytes. In some older types of firewall equipment, it is not that easy to change to it may not be a user feature. You have to upgrade the firmware. And I have heard about some older type Cisco firewall are not able to support UDP 512 byte. Another task for network administrator is the key maintenance and rollover. I would recommend all the network administrators to use the latest software to make the periodic rollover. They should use automatic signing. Even though you are using automatic signing, you still have to check whether the expiry is valid each time after the key over. The price to pay is too big. If the key over is not successful, you probably lose your job. So one thing very important is about emergency key over. The private key may be lost, or the hardware may collapse, or some internal hacker try to break down the original key. In that case, you have to start the emergency key rollover process by means of manual command. And I think network administrators need to train up themselves how to do the manual command for emergency key rollover. And all the procedure and steps should be properly documented, and the procedure need to be tested on a regular basis. And I think when DNSSEC deployment become popular in the world, large corporations will include emergency key rollover as part of the business continuity plan. So we have DNSSEC running, but DNSSEC is very difficult to troubleshoot. What shall we do? We must have the proper tool. Anybody using NS lookup here? Please raise up, right? NS lookup. Sorry that you are outdated. So I must say that because NS lookup cannot help you to verify the signature, you must change to DIG. DIG is also available in Windows platform because DIG allows you, the answer returned from DIG has the AD field, AD flag showing to the user authenticated data. So you can verify that the data return is okay along the whole chain of trust. If you are in trouble, you can add the check-in disable plus CD to check the domain name. There is a very good web-based testing tool called DNSSEC.ASIA, which in short is a DNSSEC visualization tool. If you put in the domain, it will try to scan all the signature and present you a picture layer by layer. And in case there is any error, you click on that error, on that circle, it will tell you what's wrong, and it really helps you to make your job easier. Another tool I recommend is provided by VeriSignLab. It is at DNSSEC debugger.verisignlab.com. So it will, in this picture, I try to, which domain I'm testing. Oh, sorry again. ICAM.org, sorry again. And it shows the root song is properly signed. The ORG song is properly signed. And ICAM.org is also properly signed. So it is quite handy. But as a level administrator, I do not always have a notebook with me. How about if I am on the street? How can I check the DNS status of my song? If something wrong, I want to check. How should I do? Here, there is a tool called DNSSEC Analyzer. I think this mobile application is also sponsored by VeriSignLab. So it is available in the Google Android platform, and it is also available in the Apple iOS operating system. You can see that the root song is okay, and .org is okay. ISC.org is also okay. So if you are on the street, if you are a level administrator and you may not be carrying your netbook or notebook with you all the time, you have to use this handy tool in your smartphone. So this afternoon you heard about the distinctive features of DNSSEC. DNSSEC can protect all users because it can verify the source of information by digital signature. Right now, the root zone has been signed for over 2 years, and many top-level domains are also running DNSSEC. It is now the proper time for network administrators to do their work. I think network administrators should update their knowledge and skill on DNSSEC. And actually, DNSSEC signing is not difficult with the release of BIND 9.7. Before BIND 9.7, everything for keyover is very difficult. But after BIND 9.7, everything is quite okay. Another name for BIND 9.7 is DNSSEC for humans. Very, very beautiful name, DNSSEC for humans. So even if your parent zone is not DNSSEC enabled, you don't need to wait. You can try DOV. And I would recommend that you try DNSSEC by some test domain, not your own production domain. Just spend a few $100. Tell your boss that, hey, give me a few $100. I need to test DNSSEC. If not, you'll be in trouble because I cannot guarantee you or our domain will not be affected by cache poisoning. So DNSSEC should be start now, like IPv6. So all of us, level administrator in Hong Kong, should do something. So that comes to the end of my presentation. I'm given 20 minutes, so I hope I know that I'm running a bit quick. But if you have any question about DNSSEC, you may ask me or the other guest speaker during the Q&A section. Thank you.